Hello. Hello, everyone. Thank you for being here today in this great event in the Architect Show. We're here with Andrew Waugh, a really innovative mind and a spokesperson internationally about mass timber, low-carbon architecture, and innovative construction. He lobbies and lectures internationally, and he has won the RIBA President's Award for Research, the Stirling Prize nomination in 2018, and the Architects Journal Practice of the Year Award for 2023. He is going to give us a presentation, and then we will have some time for questions. But before this, I would like to point out two very pleasant occurrences. May I have the pointer? Thank you. So, this award here is an award that has been given to this mass timber arena 2 days ago in Austria, where we have been in the International Share Architecture Awards. And this is a project that it is designed for the Vehicle Grove in Athens. It's a mass timber building, and it has a lot of potentiality about how timber is going to be implemented in Greece. So we're very proud and very thankful for this award, not for the award itself, but as a symbolic milestone that timber probably could be the timber material of the 21st century. And for this reason, I would like to dedicate this award to Mr. Elias Angelopoulos, who is the organizer of the Architect Show and a very good friend and partner the last 20 years, an innovative mind and passionate about timber that we do a lot of trips and events together, and I'm really thankful. The second occurrence is that Andrew was my tutor in the Master in Mass Timber Design in the Institute for Advanced Architecture for Catalonia, and together with Rebecca, we had a great time. We absorbed a lot of information about how timber can work, design for disassembly, and all the different inventions that we can implement. So, I would like to welcome Andrew on stage and to give us this innovative lecture that we're waiting for. Thank you.
Thank you. Kalispera. I'm sorry to speak in English the whole way through. I think I might actually sit down. I don't think I've ever done a talk on a sofa.
You can stand up if you want.
Well, I think it's quite leisure. So this is us. We're Waugh Thistleton architects. We are an architecture practice based in London. We work all over Europe and in the US. And since 2016, we've only designed and built timber buildings. And the reason why we work in timber is primarily around climate change. That was the inspiration for us, is around the climate crisis. And you know, when people talk about climate change or the climate crisis, you always see lots of graphs and Gantt charts and numbers and everything. But actually, the reality of climate change is that it's here and now, is that we are living in a climate crisis. And that climate crisis is evidenced by things like right-wing politicians and mass migration and all the things that we see in the turmoil of the world that we live in today. And the reason why I wanted to point this out is because architecture and construction play a major role in this. 40% of our global emissions are from the built environment, and by 2030, 50% of those will be around the building materials that we use. So even right now, when we're actually building less than we'll be building in the future, just the carbon emissions from making concrete are about 4 times the emissions from airline travel. So this is on us. This is on architects. This is our responsibility to make a difference and to make a change and to really transform the way that we think about success in architecture. To think beyond the the shocking, to think beyond the awesome, and to start to think about our responsibilities both socially and environmentally. And so for us, that really is about 3 pillars of practice. That's about design. We are design practice. That is about research. So about 1/3 of our practice is pure research. And that's also about sharing knowledge, whether it's working with fantastic students and architects now, or doing talks like today. It's about sharing our knowledge, sharing our understanding, and learning from that process. And this began for us in 2003 when we built our first mass timber building, our first cross-laminated timber building. And since then, we've completed about 35 projects in timber. This one in 2008 was particularly important because it was a 9-story building when really cross-laminated timber, glulam were about small buildings. They are about schools and health centers, about single-story, 2-story buildings. And in 2008, we built this 9-story building. And the idea behind that was that it was really thinking about how we could take a low-carbon material and how we could think about that material in terms of an urban scale. How can we think about a viable alternative to concrete and steel in timber? And so this building saves over 1,000 tons of carbon dioxide stored in the timber of the building. It took 4 people 27 days to make, no tower crane, much fewer foundations, and it was a safe and fast, non-toxic process. You can see a very simple construction, and it's 15 years ago now. A very simple construction, so just 7-centimeter angle brackets and 12-centimeter screws. And the entire building, in fact, I walk past this building nearly every week, taking my daughter to swimming lessons. And so I see the building every week, and it's still there and still looking good. And but beyond the environmental was also the fact that it's very quiet, has great performance, and because it's prefabricated, not only took fewer people to build, but far fewer deliveries onto site. And since then, with the scales of the work that we've done has changed. This building in 2017 was 22,000 square meters, 10 stories tall. And in concrete, it would have weighed over 10,000 tons in concrete, but in timber weighed less than 2,000 tons. So you can see that kind of like the amount of deliveries to site, the amount of concrete involved, compared to just the less than 2,000 tons of timber that it took to build this building. So I'm having some problems here with my microphone. Maybe I'm just going to hold it. There you go, adaptive reuse. So, and you can see incredibly fast. So you can see just how fast this building was, because by the time the train has gone past, the building is finished. And the scale of that, now we've taken this as a project in Norway, in Bergen, and this is looking at how we can use urban regeneration to actually help foster a timber industry. So on this project here, we're looking at connecting the old town and the new town. We're looking at how we can actually, in northern Norway, a very different attitude towards the sun than in Greece. We're looking at how we can actually bring the most sunshine into the plan by enabling the plan towards the southwest, broadening that footprint out to allow for the most amount of light that can come in to the buildings. Making sure that the heights of the buildings progress to the north west. And you can see, because these buildings are made of timber, because they're so light, that actually what we're doing here is we're using rubble, we're using rock from surrounding roadworks that are being done, and train work for new trains that are being done, using those as the foundations, working with local environmental scientists in order to actually bring oysters into the foundations, so the oysters will help clean the polluted lake, and then building these timber buildings on these oyster beds, making this connection between the old town and the new town. And we've also done a lot of office buildings as well. So this one we completed a couple of years ago in central London. This is the black and white building. And this is entirely made of timber from the ground floor slab up. So we have a hardwood timber, LVL, and then a softwood timber, CLT, floor slabs and lifts, lift shafts, and external walls. So there are many different types of engineered timber, and what we try to do in our practice is to look at the different types of timber that we can use in order to use the material in the most effective way. And so with this building here, we have 893 components, each one of which can be taken apart at the end of the project and reused. And of those components, each one fits accurately in with the next, such that the entire building is 10 millimeters, has 10 millimeters from one end to the other and 15 millimeters across. So incredibly accurate process, done by 6 people in 14 weeks. So you can see the other thing that we've done is that we have completely clear glass into the building. So the daylight that comes into the building helps to actually kind of celebrate the interior of that building and the natural material of the timber. So frequently, the glass that we use in office buildings especially has a heavy tint or has an E-coating on the outside which reflects all the UV from the building. And especially in warmer climates, that obviously is a kind of like has been the solution in order to reduce the amount of overheating inside buildings. But with this building, what we were able to do is actually to use that, to use the solar shading on the outside of the building to be able to have completely clear glass into the building. And by having clear glass into the building, that enabled us to benefit not only from natural daylight, but also from the health and the well-being, the natural benefits of working with a natural material, and how that actually enhances people's sense of well-being, sense of enjoyment, sense of, it helps reduce stress, it helps people feel better about where they are, what they're doing. You can recognize the time of day outside, etc. So across the building, because we measured so what we did is we put the building in a solar model and then measured that on a heat map across the facade, and then we used the solar shading in order to be able to reduce the amount of heat that came in during the summer, but to maximize the amount of daylight that came in during the winter. So across the facade, we have 16 different depths and frequencies and orientations, so vertical and horizontal, of timber across the building. And that was made with a thermally modified North American tulip wood. So very stable, quite lightweight hardwood. And you can see here on the south face of the building where the solar shades are horizontal, and then on the north face, west face where they're vertical. We also, as we design, we calculate the carbon. We understand what each design decision that we make in the process of considering different opportunities for the building, what the kind of carbon implications of each one of those will be. So we're constantly monitoring for carbon as you would monitor for cost in a project. And so as we go through, we're using the BIM software that we have in order to be able to quantify the amounts of carbon that we're using. And then we publish that carbon data at the end of each one of the projects in order that people can understand and appreciate not only how much carbon has gone into it, how we're making decisions to save that carbon, but also how the materials within the building can be reused. We've done a lot of research within the practice over the last 10 years. So this, and all of that research that we've done is available on our website and can be downloaded. This project is about designing low-cost housing across Europe, the new model building, each one in each country specific to those regulations. It's now available in the Netherlands and in Italy and in Spain. And this gives a kind of a whole construction system, both for architects, but also for builders and for insurers and for building code officials to understand how to build in timber. And we've done the same for offices. And we've also worked with governments, this one with the Irish government, where we've worked on a whole system for changing the Irish building regulations and promoting the procurement of timber for public buildings in Ireland. This one we've done with the local communities in the UK to build affordable housing. So this is actually where you can self-build houses. So this is just to demonstrate that this material has an opportunity to be developed at every scale. So these people building these houses here are the people that will live in them. And we've also been working within the European Union for Horizon projects. So we have 3 Horizon projects in the office at the moment. The Timber House, which is the latest one, is about the design of timber buildings, about an understanding of how we can reuse elements within a timber building, and also understanding what the health and well-being benefits are of timber. And these are studies that we've done, again, with the American Hardwood Export Council, this one about thinking about timber, thinking about trying to understand what natural materials do to us, how we respond to natural materials, where the health and well-being benefits are of being in a building that is made from bio-based materials. And you can see here, this is my brain, and my brain responds very well to timber, it turns out. And I just put these in last night, these slides in last night, because I also, talking to architects, I want us to consider the kind of materials that we use and where those materials come from and who makes those materials. Because the provenance of our construction materials is not something that we discuss in architecture. Who makes those materials for us? What are the impacts, what are the implications of making those choices? That massive cantilever, that large piece of exposed concrete, that great big steel beam, what are those decisions that we make aesthetically as architects? What are the implications of those decisions on the people that are making those materials and on the planet itself? And then thinking about timber and actually understanding a closer relationship to forests, an understanding of how timber is cut, of how those forests are regrown, is something that, again, architects should be responsible for and understand. This is a building of a different scale. This is working in central London. We won a competition to look at redeveloping this office tower. So this is an office tower from 1968, 38 stories. And what we did was to evaluate the structure of the tower to see how we could extend the existing building to revitalize, regenerate the existing building using timber. So this building is a kind of cruciform shape, and what we proposed was to put additional stories on top to test the weight of the existing structure, and then to build into the open corners of that building additional office space using the same services, the same lift shafts, and then curve that round in order to reduce the wind load on the building and the surrounding area, and then look at providing terraces to help bring fresh air through and into the building. And so with this building here, this is in Imperial. So we were able to bring an additional 25,000 square meters of additional space into the building, 4 additional stories on top. So a total building of about 83,000 square meters and using about 9,000 cubic meters of timber. And the entire project would take 30 months to build. So we don't need to touch the existing foundations at all. The timber structure is so light that we're able to actually build this without interrupting the existing foundations. And this would be the completed tower here. So you can see that what we've done is that doesn't work. You can see that what we've done is to retain some of the history of the existing building on the internal corners, and then the new building rounded on the edges, either side. And that is the number of tree seeds that it took to grow the trees that built our first tall building. Thank you.
On time and very inspiring lecture. Thank you, Andrew. So regarding, I would like to ask you some questions regarding all the process that you apply in the office, and especially about the architectural language, because we know that timber nowadays, okay, we have the CRT, we have the glue lamp, we have other bio-based materials and hybrid structure, but the aesthetic of timber, how do you combine it with the carbon performance and the construction efficiency? How we can have all of 3 together?
That's a really good question. It's a really good question, and it's something that we're learning in the office. It's something that we're really learning how to do. And I think that, for many years in architecture and in architecture schools especially, there is this way of conceiving of a building where we are conceiving of massing. We're conceiving of forms, of shapes, of objects, and then trying to, work out how we build the object that it is that we want to build. Now, nobody else conceives of a product like that. Nobody else would think about, drawing a chair without understanding what materials that chair was made out of, and without those materials informing the design of that object. And yet, in architecture, we seem to have got to this situation where the form, the mass of the building is more important than anything else. And so, what we try and do in the practice is actually to think about the components that we're building with, to think about how wood works, how far it can span, how strong it is, how it works with the wind, and all those sorts of issues which begin to govern design in reality, so that we can use this material efficiently, so that we can use this material to the full extent of its capacity. So it really is about a far more tectonic way of working. To answer your question.
Yeah, sure. But instead of tectonic, we also have the topological. And the main thing is how timber can be topological and not tectonic. And in this is the question of the architectural language. Because when you go for small scale to large scale, let's say for your projects that you have done like let's say a small installation in the city from a high-rise building, or from Trinesia, an urban planning, how this architectural language, let's say you have an identity, and in this identity you put all these tectonics in order to go from such a small to such a big thing. How you connect all this linearity?
I mean, I think it's the material that connects them, and it's the material, by prioritizing the material, by prioritizing an understanding of what the capability of that material is, then I think that begins to establish a common language between all of those sort of forms or topologies of architecture. So I think that it really is about reframing success. It's about rethinking what we see as successful in architecture. It's about understanding that the implications of our work, both on the planet, but also on people, how people use those buildings, how people inhabit those buildings, how people get better, learn faster. It really is about prioritizing humanity over the individual.
Great. And in this case, how do you think we can prioritize the post-carbon society? I mean, we know that the policies, governments, and all the idea of how we are going to use natural bio-based materials or recyclable construction materials, what are the difficulties? What do you suggest for the next generation? I mean, do you think that timber should be the construction material of the 21st century? Should let's say, promote this kind of post-carbon?
We have no choice. There's no choice. It's not a kind of like, it's not a palette of materials that we need to choose from. It's that we don't have much of these materials left anyway. We're running out of many of our natural resources in the next 30 to 50 years. So we need to be thinking about using materials that we can regrow, that we can replenish, materials that we can, components that we can reuse in future buildings, and understanding that those are important values and success within architecture. So I think that there's an inevitability about what will happen if the profession is to stay relevant.
And what about the difficulties? I see that you already are in programs like Horizon, so there are some initiatives that can promote these actions.
I think the difficulties are overrated. I don't think it's that difficult. I think, we've seen architects who've made careers out of, painting lifts orange, or, building buildings that look like wardrobes. If people can do that, then we can build them out of timber. I think it's about prioritizing what you do. I think it's about making small steps. I mean, having an understanding of the environmental impact of architecture is It's not about immediately changing the way you build. It's changing the way you think about architecture, changing what you prioritize in architecture. So it's about not having massive cantilevers. It's about not making kind of forms and shapes that are going to take additional materials to construct them. It's actually about kind of, about a modesty. It's about some restraint in some ways. But, it's not about compromise. This is something that we're always really keen to get across, is that when I was a student, people that were interested in sustainability were generally the ones that weren't very good at design. It's what you did if you couldn't draw. And I think that it was always about compromise. It was always something that was kind of slightly unpleasant or slightly kind of had a kind of like a sort of negative connotation. Whereas actually, I think the buildings that we're producing now, I think these buildings of the future, they're better buildings. They're better buildings than the buildings that we have built. They're buildings that talk about the people that use those buildings. They're buildings that celebrate the opportunities that our planet gives us. These are not buildings that are taking, they're not buildings that are celebrating individuals. These are buildings that are celebrating the people that live there, the people that work there, the people that pass by.
Exactly, how they adapt. Perfect. So now I would like to ask the audience if there is a question. A microphone there, please. A microphone.
Ποιος έχει την ερώτηση?
Ο Vasilis από Canada. Hello. This material lends itself very well to rectilinear design, but how do you foresee your practice adapting the material and the techniques for curvilinear and what you would call more creative design?
More creative.
Well, because traditionally I can pour concrete in any shape I want. It's very adaptable that way.
Okay.
There's nothing stopping my imagination with concrete, but how can I adapt my imagination for using CLT and other natural materials?
You're right. No, you have a cast material and you have a kind of and you have a cut material. It's a very different kind of form of material. Absolutely right. I would argue that I don't think that something that's orthogonal is less creative than something that is fluid, but I also think that this will emerge. This will happen. These things, this is a material that is just that is just emerging. This is a design language that is just emerging. And I think will become increasingly fluid as we become more fluent in how to use it, as the manufacturers, as the engineers have a better understanding of what we can do with the material. So I think there's just a wonderful opportunity to do more.
Is your office thinking along those lines today?
Yeah, absolutely.
And you have things in the drawing boards coming?
What, that are curved?
Well, I look forward to that, that's all.
Okay, thank you.
So another question?
I would like to ask about the metallic coating for for the fire resistance of those buildings, and for the glue that is used in the timber, in laminated timber. Are they actually ecological as well? Because timber is an ecological material, but what about this?
No. The glues that are used are not ecological. They're not. They're made of plastic. That is the absolute truth about it. Will we have glues in the future that are made from lignum, that are bio-based glues? Absolutely we will. For now, we do not. But cross-laminated timber is less than 1% adhesive. It's a very, very small amount of adhesive. And although this is something we need to improve, compared to the alternative, it is so much better. So please, don't let perfect get in the way of really very good.
Okay, thanks.
And one point to add to this, Andrew, is that also now we are expanding new techniques about DLT, about other kind of timber connection and timber joints. There are more than 400 connections that we can use without glue.
Yeah.
So it's a matter of how we want to process the things and the material. So that's why the material is very broadened. One more question and finalize the session.
No.
Fotini, it's not working.
Okay, so I'm Anastasia. I'm an architectural student. It's okay. Louder. Okay. And I would like to ask you that. Right? Okay. I'm about to apply.
Louder, please. Louder.
I'm about to apply. Okay.
I'm holding the mic.
Oh my God. Okay. So I'm Anastasia. I'm an architecture student in my second year of studies, and I'm about to apply to an internship for basically redesigning a green corridor somewhere in a major city in Athens. And I would like to ask you if you can see this material as the major material of designing a green corridor in outer space, or have you ever done a project like that before, apart from the buildings?
I'm sorry, I couldn't quite hear.
Out space.
Okay.
Of like a public space, open space. If you've done a construction that is on an open space, you mean?
Yes.
Like a park or something that is public.
Have we done that?
Yeah.
Yes. We have. You can see on our website. I mean, it's the thing about using structural timber externally is that you need to be able to maintain that material. You need to be able to look after it. Because, you know, if you don't maintain timber over time, it will degrade. It's still a very strong material, but you have to understand how to detail it, how to use it, in order to be able to use it outside over long periods of time. So it's challenging. I'm sorry I can't hear you, but I'll talk to you after.
That's why I'm asking, because I'm wondering about the life cycle of this material, and if I'm planning to design that with that an outdoor corridor, green corridor in a major city in Athens, how can I maintain that?
I think if you look at, I mean, in the UK, we have just near where I live in the UK, we have a timber church, which is over 1,000 years old, with much of the same timber in it that it had 1,000 years ago. So this is a material, if you detail it correctly, you build it correctly, can last an incredibly long time. But unfortunately, we often see examples where the material hasn't been used properly and it does degrade quickly. So it's just about understanding how the material works. And I think that actually goes back to what we were talking about before, because that understanding of how the material works as being part of the way in which you conceive the architecture is vital with natural materials. So rather than with concrete, where you come up with an idea and you kind of cast this idea, with this you're using a natural material, a material that you have to understand how it works, how it functions in the outside and on the inside.
Great. I think that we can talk about timber for many days and months. I think it will be a very nice and innovative lecture. Thank you, Andrew, for having you here. I want just to close this session. Give us just one sentence. How do you, just a message about what do you think about timber and the future?
I think timber in the future is is an incredibly exciting opportunity for architects, for designers, because I think that we can really demonstrate the importance and the vitality of architecture in the contemporary world. We can be relevant if we so choose to do. Thank you.
Thank you.